Plastic. Not exactly the world's most rigid material, but in this case that's primarily what this machine is made of. Most of the parts on this machine are 3D printed from PETG, and while not particularly rigid, they are rigid enough, it turns out, for light CNC routing. What we're looking at here is my own custom-made CNC platform V-carving a Teclectic Bunny, just to see if it could do it. I'm trying out a few different feeds and speeds here just to see what works best, and I'm using MDF as the stock since it's about the easiest and most consistent thing to engrave. I'm planning on trying a whole bunch of different types of wood, but this is already pretty impressive. The real magic, though, is in the next clip. We're going to be trying tool changing for the first time. First, we home the machine to make sure we're in a good state. Then we start the probing routine, which runs the tool to the probing area. Then we attach the probe clip to the tool while it begins descending onto the probe plate. With the touch-off complete, we've now calibrated for the length of the first tool, an 1/8" drill bit. We'll run the tool over near our starting coordinates and then touch off on the surface of the stock to set our Z0. Our X and Y origin for the job was already set off camera. Once we have our Z0, we can set the spindle to the correct speed, 5,000 RPM in this case, and start the program. The machining footage here has been sped up 4 times. In this program, we're drilling through the stock and into the spoil board below to accommodate 2 1/8" alignment dowels along the center line of the part. Once the drilling portion of the program completes, a tool change is queued and the program is paused. We resume the program to get the tool over to the changing location and swap in the next tool, an 1/8" single flute end mill. With the new tool loaded, we clip on the probe lead and resume the program, which starts the touch-off. Now that the system knows the difference in height between this tool and the previous one, we can restart the spindle and resume the job. The program here is milling out an asymmetric set of counterbores and the top portion of the matching through holes. The bit is not long enough to penetrate the stock. All the G-code here was generated in Estlcam and is being sent by BCNC. If you'd like to know more about something that you saw here or something that I didn't cover, leave a comment down below and let me know. With the top operations completed, we now need to use the 2 1/8" holes drilled in the first operation as indexing locations to flip the work about its center. With the work aligned and clamped, we can now start the bottom surface operation. As you can see, this was a successful test, and all of the holes lined up perfectly. For a 3D printed CNC, this machine far outstrips any expectations I had for it going into the project. And I'm really pleased with how the design's working out so far, and I'm looking forward to seeing what I can do with it in the future. Thanks for watching. Don't forget to like, share, and subscribe, and I'll be back with more soon.